students do join. So,
Okay. So good afternoon all. Respected Professor Dr. VIT Mishra ma'am, HOD CSE, organizing team, Dr. Sardapati sir, Dr. Bharat sir, Dr. Divya Sundar sir, and Dr. Madhurima ma'am. I am Chukuchunka, Assistant Professor. On behalf of CSE Department, I would like to welcome you, Dr. Sanjit Ningthoujam. Let me introduce Dr. Sanjit Ningthoujam. He is currently working as an Assistant Professor at Vellore Institute of Technology, Andhra Pradesh. He has done his PhD in Computer Science and Engineering from NIT Arunachal Pradesh and MTech BTech from Northeast Regional Institute of Science and Technology, NARIS, Arunachal Pradesh. His research interests include the error control in wireless networks, molecular communication, and IOV&T. He has published a number of journal articles, conference proceeding papers in reputed journals like SCI, Scopus, and Thomson Reuters. Dr. Sanjit Ningthoujam has reviewed various research articles in a high-impact reputed international journal of his field of interest. Welcome you, Dr. Sanjit Ningthoujam. You can proceed your presentation.
Yeah, first of all, thank you so much, madam, for brief introductions about me. And I'm also very happy a part of this talk as invited, and it's very golden opportunity to me. And I'm looking forward to be a part in futures also as well. And first of all, I would like to clarify that I'm also new to this field about the packet components in wireless network. And my research area that mostly I did is about the molecular communications, but I started recently it's about the packet combining techniques. So whatever I understood, whatever I learned, whatever I studied, I would like to share a bit about on that much. Yeah, I will share my presentation.
Okay.
That's okay. I think I better to off my video, right?
Yes, sir, you can off your video, but share your screen, PPT.
Is it visible?
No.
Not yet. Okay. Just please hold. Now it's visible, I think. It will come after some. So it make the list between you and us. Is it the same? Not yet coming?
No, no, Sanjit, it's not visible, like you haven't shared your screen.
Okay, let me stop it and I will say. Is it visible, madam?
Yes, yes, sir, it's visible now.
Okay. So yeah, already madam has brief introductions about me. So yeah, I am Dr. Sanjit Ningthoujam, and right now I'm working at VIT Andhra Pradesh campus. So as I told you that I'm much newly studied and newly learns about the packet combining techniques for error control in wireless network. So yeah. So the first contains is I will have some part of the introductions that is about the backward error corrections and some of the packet combining techniques that we have. So packet combining scheme itself and modified packet combining schemes, majority packet combining schemes, and after that aggressive packet combining schemes. Then at last that is the selection combining schemes. So we have a lot of packet combining schemes. So I just focuses on these other packet combining schemes. So I will discuss and then conclusions apart. So the introduction, so we have about the backward error corrections. We
Hello.
already, yeah.
Yeah, Dr. Sanjit, this is Dr. Bharat.
Yeah.
Actually, the presentation is not in full screen mode. So
Okay.
the audience, those who are watching on mobile, may have some problem. May I request you to switch over to full screen mode, and can you please share your entire screen name?
Okay.
Yeah, that's great. Yeah, thank you.
Yeah. So yeah, this is the backward error corrections where everyone knows about automatic repeat request, also called an ARQ. So the most important part of the packet combining scheme is that we have to reduce the retransmissions of the duplicate copies again and again, as we normally used to do in automatic repeat requests. So this is the main objectives that I would like to have, how we have to make it buffer at the receiver sides. And when you receive the erroneous copies, that you have to make it buffer, you have to combine, you have to make it some algorithm in such a way that we have to detect first. Accurate detection is very important. Then we have to go for the corrections. So this is what this backward error corrections normally don't have about the packet combining. Just discard the erroneous copies and the request for retransmissions. But in packet combining, we are buffering the received erroneous copies and we are trying to combine them. Either it may be perform a JOR operation, majority, or some other techniques. A lot of things that are there. And most important thing is that, see, when we receive the erroneous copies, so we have corrected bits, or you can say correct bits as well as erroneous bits as a presence. So if you discard, means that even you discard the correct bits as well. So we are trying to retrieve the original copies of the combining techniques. So this is the main important themes of packet combining, is that we have to reduce the retransmissions. Yeah. So the first packet combining schemes was introduced by Sam S. Chakraborty. So he was working in Finland during that time. It was a bit late, I think. So the thing is that we are sending some original copies. We are assuming this here. We are assuming some original copy. Here you can see I have sending this original copy, and the receiver receives two erroneous copies. First, we request for the duplicate copies, and then once you receive the second, and if it is correct, then discard the previous one, and the second duplicate copy, if you are receiving as a uh, erroneous copies, then we are performing just a simple JOR operations. We are simply performing a JOR operations here. And then here the red color signifies that it is the erroneous bit locations. So from here we come to know that the erroneous locations are identified the first and 7-bit positions while counting from the MSB. So then the brute force method is using here. The very simple packet combining started from the brute force method, where you convert from 0 to 1 and 1 to 0s and vice versa. So this is how the brute force method is working on, just to identify, just like Hamming distance, that we are finding out the error locations. So, but the main disadvantage of this is that if two locations are in the same position, that it cannot be possible to detect as normally as we know that. And also, if it is correct, then only single bit error can be corrected. So this is the one first started about packet combining, that two erroneous copies where we work on the two received erroneous copies. That's is very simple. And second one is the modified packet combining scheme. Here we are working on the three received erroneous copies. As usual, we are sending some original copies, and if the receiver receives uh, buffer it, and then we are working on the three received erroneous copies. Previous one, we are working on two erroneous copies. And the third copy is, if it is correct, then discard the previous two here. But if these three copies are received as erroneous, then what we have to do is that we are performing the JOR operations between the received erroneous copies. First one, you can perform the JOR operations between second received erroneous copies as well as the first received erroneous copies. That is copies 1 and copy 2. Then similarly, copy 1 and copy 3, you can perform the JOR operation, and copy 3 and copy 2 as well. And we are just finding out the table, from the table that we are finding out the least minimum that detected locations, and then you have to make it a table in the form of the ascending order. So here I have the erroneous bits y, which is nothing but the identified bit locations, where when we talk about the JOR operations between the copy 1 and copy 2, you will have 1 bit error locations only, and the second one is only second bit, and third one is third bits. Then we have to perform in the ascending order and make it a table. Simple. And from here we start. From here we start the packet combining scheme technique has to be applied. First, we'll go for this pickup, that C2 JOR with C1, and if we can correct, that is okay. And if it is not, then we can go to the second and third, like that. So this is something about enhance the packet combining schemes, where we work on the three received erroneous copies. And this is majority. This is very simple, that this is also works on the three received erroneous copies, where example that we have sent the original copy as 11115 times 1 as bit, and when we receive, assuming that you are receiving three received erroneous copies, and you are performed it by bit majorities, and then after that you just try to detect it, and then finding out the correct packet or not. That is what. So from here, that is very important part of this aggressive packet combining schemes comes, where what it has done here is that we have a three steps: step number 1, step number 2, and step number 3. So similarly here also, the first in the step number 1, we are performing the your majority voting, and then after that you'll find that 11011, because of my original packets copies, or you can say this is 5 times 1, that is 5 times bits, you can say. And after performing and this majority voting of these three received erroneous copies, then you can find that is 11011. This is the first step. Then second step is identifying the least reliable 2 bits. So we have to identify the least reliable bits. How we have to find the least reliable bits? From here we can see all the bits are same. Second one is also all the bits are same. Then third one, all are the bits received amongst the copies 1 and 2 are dissimilar. So that's why only from here we come to know that, oh, something dissimilar are there from the location, so that we are pointed out that is the least reliable bits. And fourth bit, you can see my mouse pointer is something. Yeah, here, that is the fourth bit from MSP. It's also the same, and the fifth from the MSP is dissimilar. So from here, we can finding out the least reliable bit is third and the fifth bit from the MSB. So this is how identifying the least reliable 2 bits from this particular example. And now the third step, searching the correct bit pattern for the least reliable 2 bits. And then what we have to do is that we have to draw the sum sequence. That first is we already find it here. Third bit as 0 and the fifth bit as 1 when we talk about the majority. Then the remaining things, the remaining sequences which made possible is 0, 0, and then 1, 0, and then 1, 1. Because there's already 0 and 1 is detected, which we have to be excluded. So from this, we have to find it out the pattern. We have to find it out the pattern. And then once you can see here at the last one, because the correct must be, because this is no, because we have sent 5 times bits 1. So that's why only we know that. But here, once we draw it, that is, you have go for the error detection. If it is correct or wrong, no. Second, also that sequences you put it, whether it is correct or wrong, it is wrong. And then third, that is, you check it for the error detection, 1. Then when you put it, then it becomes the correct. So this is the one advantage, is that the possibility of the correct bit pattern, which can be obtained from 2 to the power L minus 1, and L is the number of the least reliable bit. Up to here, any question that still having a doubt? Yeah, anyone?
It's fine. It's fine. I think it's clear.
Okay, thank you. And then this is one example of another example of 3 bits that we have found 3 least reliable bits. That previous one is only 2 reliable bits, and this is for taking the examples of finding out the 3 least reliable bits. So it's the same procedures that in the first step we are finding out the majority voting, and then from here you will find it out which least reliable bits. So I can find it out the least reliable bit is second, third, fourth from the MSB, and then from here I have to draw what are the sequences that can be possible. So it's in every pattern that I have to go for the detection. Then 0, I started putting on the second, third, fourth into that this up to the majority voting. And then already 001 is already I have received. That's only I put it. This is marked as a red color, and then I can draw this 010, 011, 100, 101, 110, 11. So after putting the last, that 11 putting on second, third, and fourth from MSB, then I can get some original copy. So this is the beauty of this is aggressive packet combining. This is started by the Leon from China, and it is basically that he was reasons about the backward error correction plus the forward error corrections. That comes the flavors of the 2 techniques, and which it will work in some other applications like for short range communications and all, where this aggressive packet combining can implement. And the fifth one is the selection combining technique. And then this is nothing but we have 3 connected branches that you can say that connected with 3 root, or you can have 3 antennas that you will have to check it which one is the highest what called the best one of that group. Means you have to find it out the minimum signal to noise ratios that among the part where you have connected 3 antennas with 3 different groups, and you are sending the packets simultaneously, and then you have to check it the minimum signal to noise ratios. Okay, so again the second point, that is nothing but ARQ based on selections and hold. This is nothing but the first part is the selections and hold. And then second one is that error location algorithm for post receptions, selections, combining things. So I would like to have a brief about this, this error locations algorithms, post receptions, basis on selections, combinings, where here what we have doing is that here also we are working on the 3 packets, because as they are sending 3 packets, or you can say same packets simultaneously. And then you are performing at the receiver side that that combining of your operations, first copies and third copy, and end operations of that result with the copy 1 and copy 2. And similarly in X2 also you can have CP1 JOR with CP2, end operations of that result with the CP2 JOR operations of CP3, where CP1 and CP2, CP3s are the receive-tree erroneous copies. So then come to the X3 also similar way that they're performing the JOR operations among the received erroneous copies, and that with that result performed an operations. And if x1, x2, and x3, where every CP1, CP2, and CP3 respectively, then we can retrieve using the original with that x1 of drawer of CP1, either x2 drawer CP2 or x3 drawer of CP2. That I just want to brief with that examples also. This is a very simple example where original copy I'm sending 8 times 1 to that binary bits, and assuming that you can work in any example. So I just work with the CP1 as where the 2 erroneous are happened in the second and the fifth bit in the copy 1, and copy 2 also similarly 1 single bit erroneous happen at the last bit, and copy 3 that is happening at first bit locations, and then accordingly that I'm performing the JOR operation, that is x1. I'm giving you the example of the x1 only, x2 also, x3 also you can perform. But in this example, when I draw it, that it gives us an original copy when I perform the x1. So after this, copy 1 JOR with copy 3, and the copy 1 JOR with copy 2, and that results perform the N operation, and then you have got it, this binary bit streams, and then original is nothing but with x1. With x1 is this one, that the receive of that result, and again JOR with of CP1, where x1 relates with the CP1. Then I perform the JOR operation with that, the result of that, and then this copy 1, and then we can retract the original copy. So many researchers have done about the combinations again. These are just a simple packet combinings where I have explained right now packet combining schemes, and then the modified packet combining schemes, majority, and then aggressive packet combining, and the selections and whole. So these are the simple packet combining schemes. Again, I have seen so many other researchers who have started working on combining the packets of this technique, and then they are trying to correct more bits. Here we can see that at most 2 bits can correct, not more than that till now here. So, but the only thing is that talking about the complexity. So about the complexity, this is not that much complex. So that's why only it tries to work and implement on in short range communications, and at the same time these packet combining techniques are just for reduce the retransmission of duplicate copies, just maintaining some buffer, and we try to retry. As I inform you that that in the received erroneous copies we have some correct bits as well as erroneous bits, so we are trying to retrieve the original informations. Yes, I think any question, because as I have concluded, as I have a short presentations.
Okay, thank you, Dr. Sanjit, for such a sweet and short presentation. So these packet combining techniques, so I hope they have been in use for quite a long time. So now we are noticing a paradigm shift towards 5G 6G communication, and we have we want to transfer gigabits of data. So how do you think if this combines will still be working in future, or they need major modifications?
Regarding what you are talking is about how many packages we can combine, up to
Yes.
how. So actually, the first thing is that we are trying to reduce, because the minimum packet combining, that is up to 2 packets if started first. But even though that if the 2 packets, if they are happening, if their error location happening in the same position, that would not be possible to detect. So if it is not possible to detect, then correction is not possible at all with this technique. So that's why only we are trying to work on the minimum 3 packets or 3 duplicate erroneous copies. Because if we are increasing the packet combining, that there should be a buffer problem at all, and at the same time, it also decreases the performance about the throughputs and all. So we are always trying to by at most is three received erroneous copies. We are trying to work on it and then finding the correct bit strings, or we can say the original packet.
So,
So, I have a question.
yes, please.
So, what tools may be appropriate for error detection? Like,
Here, there is regarding about this is packet compiling. Some of the researchers they have used in method till now. So many other things as you can use. So, but for the trial and everything, a lot of things are there. But for this, is they are mostly focused on the mathematical. So they are using the mathematical.
so,
Yeah, sir.
Yes.
Uh, Actually, with respect to time, the wireless sensor networks has been evolved into different ad hoc networks also,
Yeah.
uh,
Obviously.
like uh, like vehicular sensor network, or let's say flying ad hoc network, or aeronautical ad hoc network. So my
Yeah.
question is the approach that is used in the WSN, whether the approach can be used in other ad hoc networks,
Yeah.
similar
This
approach, or
will
any
be
modification
applicable.
is required.
Yeah, this will be applicable. And most of the thing is that, as I told you, that about you are talking about the sensor, we have to be correct at one sort. But sometimes it may not be. But we are trying to find out a minimum communication. So that means that it will also be helpful in kind of a sensor or any other uh, communication.
Okay, sir.
Okay, Dr. Sanjit, I
Yeah.
have one question.
Yeah.
So like nowadays it's like security is very important. Okay, so
Yeah.
in this packet combining, can we incorporate this security concept or any challenges that can be seen in the this packet combining, and
Regarding
then we
about
can
the
resolve it?
security,
Yeah.
this is quite different from the security talking about. This is error control. Security is something I don't have that much knowledge about the security, but error controls us how we have to retract the packet this and that. But security is different from there. I don't think so. This techniques will be feasible to the security. Security is something.
Okay. So again, Sanjit, I want to ask, like, you can move to the slide number 9.
Where is this
Yeah.
slide number 9, 8, 9? Yeah.
Yeah. Can you explain this one more once again? Means just I want to like because it's written just like I couldn't
Yeah. 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 Yeah.
clearly.
Thank
It's not that much clear. So can
Yeah,
you
from
explain
here,
it?
that is step number one, step number two, and step number three. I think all of you have any doubt regarding about how we have to find the least reliable 2 bits or 3 bits according to the received erroneous copies? Anyone having a doubt, and please let me know, because this is quite interesting part of aggressive packet combining scheme. As I also feel, okay, this is something what we need to do, and we need to extend more. Or if you want to do some work more, then we can combine this packet combining, and then nowadays the channel state condition is like sometimes good, sometimes bad, sometimes it's happening anything. So when the channel state is something like our network state, or you can say the channel state is bad, then which is more applicable? Because as I in my conclusion also I have written that it is neither any reason or no logic to apply the same technique. We are just trying to modify that is some algorithm in such a way that okay, this channel is that, so that we can implement this algorithm, then it will be feasible. So one algorithm repeatedly uses either in the bad state or either in the good state is not effective because it's a dynamic in nature regarding about this the bandwidths and all. So that's why only I also feel very good regarding about this aggressive packet combining schemes topic when I started learning. And it's quite simple. So also, when you want to implement the hardware, also this will not be complex. So the more important thing is that we want always simplify um, hardware on the other hand. So this is just about the N operations and JOR operations, most of the things said, but repeatedly it will take. But if we can correct with the simplified hardware, that will be very good. So these are the beauty of this aggressive packet combining schemes. And also, moreover, that this can be implemented as one of the uh, participant told about whether it should be wireless sensor network applicable or not. I fully agree that this will be applicable if you work on much more effort than to these topics and all. So again, yeah, I come to the point: is there any having a doubt regarding about this aggressive packet combining scheme? Because this is a simple example that I can show you. Then the previous, then after that, slide number 9 is quite working on the 8 bits. This is working on the 5 bits. If any one of you, yeah, if any one of you feels interest, then I will be very privileged and happy that at least just by this 30 or 40 minutes presentation, if any one of interested and start working and then implementing and then especially to the research scholar, it will be very helpful. And even I'm also working that whether this is applicable in the molecular communications or not. Because I started working on the molecular communications and Internet of Bio things. So whether this kind of uh, packet combining schemes will be feasible or not. Yeah.
Yeah, Dr. Sanjit, I was wondering, nowadays a lot of IoT communications, they
Yeah.
are preparing to get connected to the cellular networks. So
Yeah.
for some kind of situation, suppose there was a power outage in some area. So when the power's backup is restored, I think a lot of devices will be trying to communicate to the base stations. So the number of channels are limited. So in this case, usually they propose a gateway device, which generally combines multiple IoT packets and send
Mhm.
this to the base stations or whatever access point. So I have two questions. Does this packet combining technique work well with gateway? Second thing, if this combined technique is hardware level or software level, what do you think? Which one would work well?
First of all, as from as I'm from the computer science students, I would love to be answer in this is in the software level. But if someone who wants to work because it's diversity, people different. So if they want to work on in the hardware, also that is not out. But as I'm from computer science, I don't much knowledge about the hardware, but it has to be
Yeah.
implemented in the software level.
Okay. Thank you.
Yes, any, and I have received a lot of very nice interactions and then good questions also. I've got it, learned so much things on the other hand.
Okay, I request Madhuri ma'am to give a vote of thanks to Dr. Sanjit Ningthoujam.
Thank you, Shukru ma'am. I hope I'm audible.
Yes, ma'am.
Ma'am, I'm audible.
Yes,
Yeah.
ma'am, you are audible.
Yes, ma'am. Thank you so much for giving me this opportunity. On behalf of the CSE team, the whole department, I would like to thank Dr. Sanjit for giving us his time and explaining us how, with using error, the packet combining techniques, how we can avoid uh, security mishaps in wireless network itself. He has showed us with some basic example, which is again, it needed in-depth introspection of how things happen. I was just going through, I realized it's more like, we don't realize, but more like frequency hopping and all that. It's quite relatable. And with an example, sir, you have showed us how it goes. This is a Saturday evening. We were expecting more students, but unfortunately, there was the number of students were less. So we would need your presentation and the material. I'm very sure our research scholars would follow up. Thank you so much for your time, sir. I would like to thank all the participants, our HOD ma'am for convening this webinar. This was the 35th edition of the SOA WAL weekly academic lectures, and we had Dr. Sanjit with us today. I would like to thank our assistant HOD, Dr. Sarda sir, for being able to bring us everything together in one place. And I would like to thank Chuku ma'am, especially for getting us such a nice topic and such a nice speaker. Thank you, ma'am. Thank you, sir.
Yeah, thank you.